This is an aspirational photograph for the working group. Wouldn't you be rather doing this than working on Quic still? Let's get it done. Sorry? That is the neighbor. I would highly recommend it, yeah. Although we found a place last night that...
That's not the neighbor. There's ice in the neighbor.
Sorry?
There's ice in the neighbor.
Nicer than the neighbor, yeah.
There is ice in that drink.
In that drink? No.
You said neighbor.
That's the neighbor.
Mine didn't. Mine had ice in it.
Mine did not.
Oh, well, there you go. Maybe they just poured gin in the glass for me and I was perfectly happy.
You were perfectly happy with that, weren't you? So this is the Quic working group. If you have come for a different working group, you're likely to be disappointed, but you may still be engaged. I haven't prearranged scribes. Do we have any volunteers? I won't pick on Sean Turner because we picked on him too many times in the past. I don't know how much faith that Ecker would do it. Jana? No? Okay.
I'm just arranging it to be evenly.
Patrick McManus is a hero. Wait, Jana's going to do it? It's a Fastly production. Fantastic. Both of you do it together. Good on you. Oh, you want to? Yeah, I can do the right. And can someone, hopefully near the microphone, volunteer to be Jabber Relay? If in fact, thank you, Eric. Fantastic. This is the note well. I hope you're familiar with it by now, but if you're not, these are the terms under which you participate in the IETF regarding things like code of conduct and intellectual property. Please have a read, and you can find more information on the IETF website. That's not, no, we're not using that. We have the blue sheets, check. We have a scribe, check. Jabber Relay, check. We're ready to go. So our agenda for today, we're going to have a hackathon report briefly from Lars, and then updates from the editors, including updates on the operation drafts, which we need to start paying more attention to. Then we're going to discuss a few brief issues that the editors have identified. I think one of those may have been superseded, overcome by events. Martin?
Yeah. So the version negotiation one is not going to be addressed in this room based on the discussions I've been having with people. Unfortunately, I do want to still introduce the problem so people are aware of what's going on. The variance thing has already been addressed, but I think Martin Seaman has some other material to discuss regarding the handshake that's kind of some corner cases that aren't exactly ideal. I think that's all the two changes there.
Great. And then after that, we'll have a quick discussion of the human rights review document that came across the doorstep. And as time permits, talk about making Quic deployable from Ian, quick load balancing from Martin Duke, and finally quick unreliable datagrams for Tommy Foley. We have another session tomorrow, and that session is almost entirely devoted to the spin bit. So if you've come here expecting the fireworks, you have to wait a little bit longer. At the end of tomorrow, we'll also do some housekeeping in terms of looking at our charter, our milestones, reminding people of the upcoming interim, and that sort of thing after the spin bit discussion. Any bashing on the agenda? Okay. All right.
I guess you're putting this at me for the interrupt report. So I don't have any slides. Anything else? So the last few stickers are in the back. If you want to grab them, they'll soon be worth a lot on eBay. Right. As Mark said, tomorrow we're going to do the housekeeping. Spoiler alert, right? It seems highly unlikely we're going to ship something to the ISG this month. Yeah. Sorry, Spencer. You had to find out this way. Tomorrow we'll tell you when.
You didn't tell me to sit down.
But that'll be one big part of that discussion. So we're not quite done yet, but that'll happen tomorrow. In terms of interop, we had, as usual, during the hackathon, a table. We actually had 2 tables this time with people that are implementing Quic, and that basically we're testing the current implementation drafts. I think we had like around 10 implementations participate in some form. It's looking better in terms of getting back to at least basic interoperability in terms of version negotiation, handshake, data exchange, and closing. There was a big sort of disruption when we redid the Stream 0 thing, and we're still sort of seeing the after effects of that, that there's a bunch of implementations that haven't moved to one of the new versions that have the refactored Stream 0. But sort of we hear that it's happening soon. We don't have a whole lot of experience or a whole lot of interop with some, I'm going to call it advanced features, but it's actually pretty basic functionality, such as like key update or connection migration. There's very few stacks that are doing it, and I think there's very few stacks specifically that I would call like, the ones that are going for large-scale deployment that are currently doing it. That's a bit concerning. It's one of the reasons why the milestones are probably unlikely. Right, so this is the spreadsheet. Greener is better, basically. Darker greener is better, more letters are better. Clients are down vertically, servers are cross horizontally. So you can see there's some white. I tried to move the implementations that haven't shown up sort of to the right, so to concentrate the information a little bit there. But there's still some white and some very light green, and that's not super good. But it's looking better, and I think the trajectory is there. We're going to do another interim meeting with an interop event before it in January. Hopefully, it's going to look a lot better then. And then by Prague, so definitely by Prague, we should be interoping around -17, probably already in Japan. But I really hope that on -17, we're going to see a lot of more dark green. I know Alan wanted to say something specifically about interop around HQ. I don't know if you're in the room or remotely, or if somebody else wants to say something in his stead. I don't know if you're qualified to summarize where we are with that. But I think we were somewhere. Jana,
I don't know if this is a bug in I don't know if this is a mistake, but I'm just curious to understand how does that ATS manages to have fewer features with itself than it does with others?
Don't ask me.
All right.
Alan Jabber would like to say that QPAC had 3 implementations.
Did they interrupt?
No.
Okay, so there's work.
Well, those 3 interrupt. I have an implementation that disagrees with them, so we have some issues to sort out.
Right. So the good side is, right, there's a lot of activity, and I think it's even increasing, right? There's more and more lines and columns on the spreadsheet, although some of them have been remained white for a while now. But we are still feeling the after effects of the Stream 0 refactoring. Plus, the editors are really good at changing other stuff. And so I think the goal is to have -17, which is the one that's currently open for surgery, be the last one where we're going to do large changes that are not motivated by strong interoperability problems. So the hope is that really -17 will be the thing that we're going to let sit and simmer for a while, and let the implementations actually catch up and do some much wider scale interop. With the caveat, and I just said this in TCPM, so on the recovery draft specifically, I think we are still trying to get more help from the TCP guys to make the quick recovery as compatible and comparable to what TCP is doing as possible. And so I think for recovery, we are probably going to see some changes that are not necessarily only going to be driven by interop. However, so recovery is complex, but it's not actually a whole lot of code that needs to change for it. So hopefully changes to recovery will not cause, but they shouldn't cause interoperability issues to begin with, but they also hopefully don't disrupt the implementations too much. Christian.
Christian Wittemer. Lars, when I look at this matrix, please leave it on. When I look at the matrix, as you say, there is a bunch of advanced features that are not tested at all. Like, we have 2 academic or prototype implementation that do migrations.
Right.
And pretty much nobody else does. And that tells me, I mean, we should seriously consider at which point do we decide that, okay, the reason that nobody does it is probably because the spec is too hard or something, and we just cut it for V1.
We should. My feeling, I'll put it this way, is that we haven't seen a lot of interop around that because the rate of change to everything else is so high that you're going to spend a lot of cycles as an implementation team basically on keeping up with everything else that gives you basic interop that people just haven't gotten to that yet. If it remains the case that people aren't getting to that yet in the next couple of weeks and months, I think we should definitely have a discussion on what to do with those features.
And I'm going to point out that we seem to be migrating from a discussion of the interop results to the planning of our future and how we handle our schedule. So
it was just I was just reading the data, and the data tells me something.
I'm looking at the queue behind you.
Okay.
The data tells you should help other people with their implementations.
Which is closed now.
And feel free to tell me I'm out of order and that you want to raise another point. But what I noticed about this graph, and also about generally my experience, and I've written this course before, is that things that are easy to test get tested, and things that are hard to test do not get tested, even if they actually might be implemented. And I live in particular fear of recovery, but even like my experience has been there's basically no difference between 14 and 15. And I updated to 15 in 5 minutes, and was just too lazy to sit around and try to interrupt with everybody. And so, and that's easy. So I guess I would be up for, and I know Lars and I both done some work individually, trying to figure out some set of arrangements that would make it easier for you to test things. And that's the only way we're gonna be able to test recovery. So, my idea would be I could just take my implementation, put in a Docker image, and drop it in a test harness, and we'd come back with this matrix. Maybe that's too fancy, but so I think if other people are like-minded about this, maybe we could have some sort of small discussion about what to build in collaboratively build a tool chain for this, because I just don't see literally we could spend the first day in the interim with implementations that actually all work pretty well, just getting this matrix filled out.
Janayangar, I'll just note that this is not a complete set of all the features of Quic.
No, of course not.
No, I know. I'm responding to, I think I should have started with that. I'm responding to Christian's point. We are nowhere near the point where we are deciding or even thinking about what to cut out of this stuff. So I don't think we should be going down the path of discussing that right now.
So I agree with Ecker. So it's a good topic for how to automate some of this, and some of us have some automation for their particular stack, but there's nothing that generates that whole matrix, and that would be very useful. The other thing that would be not so getting something like a packet drill suite is difficult for Quic, but because it's encrypted, but that would be very useful. So there's some discussion that maybe we should have around one of the interop events about what we can do.
I guess I would think before then, because otherwise we'll spend the interop event writing that test harness. Again, I guess I'm going to raise my hand if there's other people be interested in working on this, come find me or raise your hands now or something, and we'll try to get together and do something. I'm really super flexible at what we do, but I like to have something happen because it's just, I say, it's just incredibly expensive, and I'm really quite worried about there's got to be 9,000 recovery cases that we have to test, and every single one of them is going to need testing, and I don't see how we're going to possibly do that manually.
If you're a professor that has master students, it's not really a PhD topic, but it's certainly a master thesis topic. That would, eternal fame.
Janayangar, on this topic, there was a test suite that was written by some folks. They showed up in London. Have we heard anything from those people?
Do you mean Quic Tracker?
I don't know. I don't remember what it was
So
called.
Olivier, student, is working on that, but that is more like a conformance test. It could lead to this, but
I'll
yes.
look it up and I'll.
Yeah.
Yeah. Thanks.
And Ecker, if you need a repo for that or something, just ask. So, Mr. Thompson.
Yeah. You want me on the front?
Take your pick. The whole room's a pink box.
Not interested in mucking around here. Right, so what happened in 15? This is since the last time we met as a working group, include that at the interim. 15 has quite a number of changes here. There are a few other minor ones that are not in this list, but these are the ones I think are of note. Even the first one's not really a change. I think we changed some packet numbers as a result. But we took the two frame types and merged them into one. So whenever we talk about ACK now, we're talking about an ACK that may or may not have ECN counters in it. We litigated the design of ACK at some length and decided that it wasn't worth changing. We have some signaling around the ACK delays. We now insist on validating the presence of the retry and having the server prove that it was the one that saw it. That's new. What is also new is that there's only one of them. Obviously, that design doesn't work particularly well if there would be multiple retries, and there was a number of other reasons we got rid of retries. We have the design team come back with some recommendations about how to deal with connection IDs in their ongoing management, and added a frame to deal with that. And there's also some changes in there to prevent deadlocks. I think Martin Siemens' talk goes further into that and the consequences of having that design. So we're likely to see a little bit more change in 17 around that one, maybe. HTTP and QPAC had a few kind of major changes. Settings are now variants. And this is the one that I hate. Largest reference is encoded modulo max entries. I think I lost that one. That's awkward. And then we have a new static table that I don't think anyone's really all that happy with, but it's there. And the next slide has all the changes in 16. Right. You'll notice the diffs look rather large. I've got the table of contents in the next slide, which is probably the more interesting one. So the transport document, we decided to flip on its head and shuffle everything around. So you'll notice that there's a lot of text moved. There's a lot of new text around all of it as well. And we're continuing this work in upcoming versions as well. But the idea is that we're going to talk about the things that people care about most first, and then talk about the stuff that implementers care about most last. Let's go. HTTP got a new structure as well. I'm not sure that that's all that different to how it was before, but this is what it looks like. It was cleaned up a little bit and worked for reflow. QPAC is having a similar rework done, but that hasn't landed yet, I don't think. We'll see that in 17, or along with 17. Because, this is what that looks like at the moment. It may shift around a little bit as that PI evolves. I think Alan's almost finished with that one, so we should see that relatively soon. Next. Okay, 17, fun things. So we are going to change the layout of the first octet in both short and long header forms. Those changes have been held based on a number of things. So we had the great Google Quic migration event occur. So that allowed us to reclaim a couple of the bits that we were sort of holding in fixed positions during that transition. That seems to have been successful based on the reports that I have from Ian. So we have our fingers crossed, and we're going to continue along this path. We're going to take those bits back and we're going to assign them to things like spin bits if that's the outcome of the discussion tomorrow. Some people noticed some interesting problems with the way that we were doing stream limits and how that interacted with blocked, and then we went back and looked at it and thought that probably the best thing to do is completely restructure the way that we allocate, we grant new streams to appear. And so we're doing that based on counters rather than the maximum identifier, which makes them much more like the flow control than they were previously. It just means that we have more frames now. It also means that we don't have crazy situations where frames can have values that are completely invalid in them. So I think that cleans things up a little bit. Colin, you had a question.
Hi, yeah, it just takes me a little while to get to the mic. Colin Perkins, for the first octet changes, there was a multiplexing discussion in AVT core this morning. So
yeah, I'm going to go over that a little bit more. I've got a separate deck on that one.
Okay,
I'll go through that change afterwards. I've got the conclusions to the discussion on those slides, and I'll just walk through them in a little bit more detail. Okay. I renumbered everything,
Again,
which Lars was super happy about. I also put E's in reset stream for all those people who have been irritated by that. And there's a bunch of other things that we're going to be talking about here that might get into 17. But as Lars said, 17, well, it is our vain hope that 17 is the last one we ever have to make real changes in. And so there was one more that Kazuho prompted us to make as well, which is we reshuffled the order of the fields in the new connection ID frame because they were a little bit weird. So things like that. Now's your opportunity. You have about 2 weeks to get your pet hates addressed and merged and looked at, but the bar's going to go up pretty significantly after that time, I think.
Yeah, I mean, my ask was going to be a little more time than that. A month seems a little more appropriate given the time of year.
That would be fine.
I basically, like, I want to have, given there've been a bunch of changes, I want to have time to read this back from start to finish and make sure like I feel like make sure I have my head things I'm the way about, right?
Would you object to that? To us doing say 2 iterations if issues came out, so have an 18?
Yeah. I'm asking. Yes, I'm just asking. Like,
don't freeze just yet.
Yeah, that's what I'm asking for. Like give people time to like pull their heads up and just like get the whole thing from start to finish.
Right. That's fair. And so the point here is this is your warning. We're going to start that process now. I don't think there's going to be a hard edge to the other end of it. It's just that we want to make sure that come some reasonable time before we meet again in Tokyo, things are stable and we can start to talk about things like deployment. John?
Janai, just to respond to what Iker said, to be clear also, this doesn't mean that if there are actually egregious errors in there, we won't address them, right? Of course, we want to do that.
Yeah. I think I'd expressed it as the working group agrees, I hope, that we need a period of stability to let implementers catch up and see how this goes.
Yeah. And I want to avoid egregious changes after some point, but Eka's request is perfectly reasonable.
I guess all I'm trying to get at is that, like, I feel you know, that because we only have these partial implementations, and because every time we do an implementation we find infelicities, you know, like, I don't want to put us in a position where there are things like the future is bigger than the past, and where things that like just suck but like aren't actually death, like are things that we just can't like say, oh, we can't fix because like we like agreed to freeze something. That's like what I'm worried about.
Yeah, that's not the agreement we're making.
No. And of course, outright bugs will continue to get fixed. Do we have another one on the next slide?
I think you have one more.
Yeah, the idea is that at some point very, very soon, we'll have a stable protocol. That means we need pretty strong justification to make changes to things that will affect interoperability. My suggestion is that that if we get issues open that are sort of speculative or suggest improvements, we're going to be a little bit more aggressive about closing those sorts of things politely. But if people do want to open new design issues because they've found bugs, I definitely want to see those raised. And but if you're not sure whether this has been discussed or whatnot, maybe discussing with the list before you open issues, then that might be the best way to do things. Of course, editorial stuff we take any day, especially in PR form. I think that's all I have. Can you go to the next deck? Unless anyone wants to talk about this topic a little bit more. Yeah, the packet, octet 0.
Are people reasonably clear on that? It's not that we're saying we're going to shut it down and not take any more changes, but we need a period of stability to get some assessment from the implementations. In an ideal world, we will prove that what we have written down is a great specification, and then we can move forward. If we find problems, then we'll deal with that.
Yeah, but one of the sentiments I heard expressed was that because things have changed quite a lot, quite often, it's been very hard to get to the point where you've got an implementation that is good for deployment. And one thing that we're kind of lacking is the experience in deployment.
Exactly.
And I don't want to ship this RFC without considerable experience in deployment. And so we need to get that process started pretty soon.
Right. And so, you know, changes asking for, well, renumbering or aesthetic changes or whatever are not going to be helping us get to that.
Yep. And so that might mean that some things will suck in, you know, indefinitely. We're sorry.
So octet 0?
Octet 0, please. Because I think this goes to Colin's point, and I think this is probably the best one to do.
Yay.
All right. So this is the outcome of the discussion in New York with colors and letters. So the long header packet will look like the first one. So we have the first bit saying that it's long. We have what I'm dubbing the quick bit in the next one. We have 2 type bits that allow us to distinguish between the 4 different types of long headers that we have. And then the rest of this is encrypted. So the orange here is we're using the packet number protection scheme. The short header, we have the short header bit, the quick bit, we might have a spin bit, and everything that's not those things is encrypted. And under encryption in both of them, we have a packet number. The short header will have a key phase bit. And that means that the packet number encryption key won't rotate as the keys rotate in key updates. Thanks, Kazuo. Next. So the common part, as I said, there's not a lot of new things there. Next. This is just for the record, I guess. I have a straw man here for the allocation of code points to the various types of long header packets. That's negotiable, but one of the desires expressed was that people could use some combination of bits in the long header to identify things that have client selected or potentially client selected connection IDs in them, so they can be hived off in terms of the load balancers and routers and things like that. So we'll try to preserve that as much as possible. The other thing is that the spare bits, we're gonna say they need to be 0, and maybe you can negotiate their use afterwards, but 0 will be the defaults, and probably in the long header that means that 0 will be the values. We're encrypting them so they'll look random on the wire. Okay.
Is this must be 0, must ignore, or must be 0, must check?
Must be 0, must check.
Okay.
That's my put. I mean, I'll take anything else, but this is really just a straw man. If people have an argument for anything else, I'll take that.
Okay. I'm sorry. Yeah, it gives you 2 more bits of integrity check. Sure. I anticipate a 30% chance of needing to have 1 more type bit at some point in the near future, but you know, I don't have a reason for that. I'm just saying, like every other time we've saturated the entire space, we've been like, actually, this was a shitty idea, but
we have spare bits.
We have space, so that's fine.
Yeah, we have spare bits, and we can take them back if we truly need them. Yeah.
David Scanazi, Google. This makes me uneasy. One of the first one was what Ecker was saying, that the type is kind of a registry where today we only have 4 values in there, but it was kind of nice to have it extensible, but with 2 bits, we're not going to be able to fit a lot more.
Give me one example.
That's the point of extensibility, is that we can't think of it yet.
Yeah, if we did that all the time, we'd have all of these extension points hanging off us, and
then why do we have frame types that are VLIs? We could only like limit it to 5 frame types by that, you know? Anyway, so.
We have example frame types.
Okay.
Yep.
So first point. Second one, I feel like we're burning 2 bits on the packet number length that are already encoded in the packet number itself. Again, I don't have
This is moving them from the packet number.
I see. But that doesn't really allow us to encode that many more values, right? Because I
4
can't
times as many.
Yeah. Sorry. Okay, fair enough.
Yeah.
I can see that. Thanks.
Yep. So yeah, the point that Eka made off mic was that the 8-bit packet number is much closer to plausible than the 6-bit one. Oh, it was 7, but yeah, it's that much more plausible.
Jonathan Lennox, how much of this is going in invariant and how much of this is just in Quic V2?
This is, I don't know who's doing Quic V2. If you're doing
No,
Quic V2, that'll be great.
I know, IETF. I thought IETF Quic was Quic V2. I thought we decided that.
Yeah, yeah.
Oh, they got rid of that? Oh,
yeah.
sorry, whatever.
So all of this stuff that we're talking about here is entirely under our control. So the next version of Quic, whatever that's called, can change everything that we decide to do.
So none of this is invariant?
None of this is invariant. Okay. The only thing that's invariant here is that first bit. Okay. I think I have another one as well.
So particularly the second bit, your Quic bit is not an invariant.
The Quic bit is not really a Quic bit. I mean, it's a joke, but in
But I mean, it's-
this version of Quic, that bit will be set.
Okay.
Yeah. I think we have another slide, I think. And it's the same as I described before. So we'll encrypt the spin bit here if we decide not to do spinning. But otherwise, the rules are the same. I think that's all I've got on this slide, is it? Oh, yeah, let's not worry about this one right now. Yep, all right, done. Thank you.
All right, thank you. So that takes us.
Colin is running to the mic.
Oh, stick around that mic, maybe.
This room is really big and it takes a while to get to the mic.
There's chairs closer to the mic, Colin.
Right. So from a very quick look while you were giving that talk, this looks to avoid the obvious collisions with things like RTP and stun. Please do coordinate with AVT Core because they have a draft on this demultiplexing. Just to make sure everyone is happy with that. I think it would be really useful if we could get demultiplexing with stun as an invariant. The bit patterns for that. The appropriate bit pattern so we can always do that demux.
Is he on this?
It's something we have discussed before in this group.
Jana Iyengar, are you trying to put that in there so that we don't have to litigate that again in a future version of Quic? I mean, that's a reasonable argument, but I'm not sure I buy it fully. But
I think we're going to want to do peer-to-peer Quic, which means we're going to need net traversal, which means we either need to have an invariant that we can demux with stun, or we need to reinvent that functionality in Quic. And I think it's much easier to have an invariant that we can demux just based on the first bits, which we have if we stick with those first 2 bits that we have.
I want to say that the whole notion of invariance is things that we were choosing to keep fixed so that we wouldn't ever change them, and it's a minimal set. There are things that can naturally become invariant just because that's how deployment works sometimes, and I'm fine with stun demultiplexing being one of those. I don't think we need to codify it. Yeah.
My feeling is it's likely to be extremely important, and we're basically making invariant 2 bits. The first 2 bits of the packet, and that's it. Yeah, it's just this one bit.
Yeah, I don't think I'm in favor of that for several reasons. First of all, there are going to be an enormous percentage of the quick connections in the world which never need to be demuxed with stun, like all the ones between web clients and web servers, basically. So that's point one. Point two is the primary need for demultiplexing is the endpoints of demultiplex. And the primary need for invariance is people who are not part of the connection to be able to do things with it, do things or not do things with the quick packets. And so the endpoints are perfectly capable of arranging like to only do versions of Quic which do not need demux system. And so I don't think the purpose of invariance is not to like nail down design decisions in perpetuity. It is to instruct people who are not part of the connection how to manage the packets.
I would expect that if we want peer-to-peer to work, it's one thing which the firewalls and the middle boxes will need to will need to allow through. And there's already a lot of infrastructure that understands stun. So I think this may be something where we care about the on-path devices.
Okay, so now we have Miria presenting about the ops drafts and not Brian.
Yeah, hi, I'm Amelia. So we updated both of these, both of these drafts, and we can go to the next slide. So the manageability, we updated them both based on issues we had in GitHub. So the manageability got one new section. We added some illustrations, some ASCII art for the quick handshake, and we added some text and security considerations, but there are no open issues in GitHub on this document anymore. Of course, we have to update the document to align it with the protocol specification at the very end, but this is in pretty good shape. Next. There was a couple of more open issues on the applicability, and we did a little bit more work. We have 3 new sections, which got written and reviewed and merged into this version. There was a little bit of editorial work on information exposure and connection ID based on the changes that had happened on the protocol since then. And we have 2 pending PRs for the next version. Thank you, Martin, which are also ready to be merged, I think. Yeah.
The first one there will need to be held, I think, because that's conditional on, that made some assumptions based on in-flight stuff that will not necessarily manned. So that'll need a little bit of work.
I mean, as I said, we have to rework a couple of things anyway when the transport draft changes. So we can merge it and change it later, or we can hold it. I don't know. It doesn't really matter that much. Okay, next slide. Unfortunately, we have some open issues and we need a little bit of help there. Some of these things are just questions about what to do and if you want to do it at all. And some of these things we need actually people writing text because we might not have the best expertise for that. So there's issue 11 and 29, which are still talking about giving more guidance about how to create your connection ID, because you can encode information in the connection ID for the network. There was a proposal, proposal to make a recommendation that you should include a MAC in the connection ID, so on-path device can also check that those informations are kind of correct. That has a question mark because there was some discussion and it was not clear if this is something you want to recommend or is needed or whatever. So more input is definitely needed here. And we addressed issue 29 to some extent, but there's another question if we need more guidance. There is an issue open, that's issue number 14, asking if we need more guidance about application visible errors, like what should applications do with those errors? I don't think there are many different errors visible anymore, but it would be nice to give some guidance. Doesn't have to be much guidance, but we would need some input here, like from HTTP people or other draft authors. There is a question if we want to explain the idea or the hack maybe, that you can send, if you have a message-based application protocol, you could send 1 message per stream, and then you can cancel the sending if you don't need this message anymore, which would like enable some kind of partial reliability. So I mean, this is a way how to use the Quic protocol, and it's a hack to get some partial reliability. And the question is, do we want to spell it out, or is it something we don't want to recommend? And I see people coming to the mic.
No, please do not recommend this. This is not a good idea.
I mean, not recommend, but I mean, it's, so you don't want to even talk about it.
When I heard about it, like I had to like duct tape my head back together. So no.
People can do it still, right? Even if you don't like it.
I think it's completely reasonable to do this for what it's worth. I don't think we need to recommend this. I don't think we need to say anything about it. I think people who want to do partial reliability know exactly what it implies, and I think they will do it. I don't think anything breaks, by the way, when we do this. I don't think anything breaks. So
the sub-question here was, do we want to give some more recommendation about when it makes sense to cancel streams, or like on a more general level without having the specific use case in mind?
I'd have to go look at the text, but and I think I get that the working group has decided not to take on partial reliability as a work item just yet, but we know how to do it. We have drafts. Let us not document things which we know have better ways to do.
No, but I mean, this is documenting the way to use the current Quic protocol, right? Like you can use it that way if you want.
You could also use the hammer. Hammer versus the hammer.
So to be clear, this is not. I don't think we should really get in the business of trying to figure out what applications should not do, especially on things like this. API use is always something that we figure out how application use later. But if somebody thinks there's a problem in doing this, I think that'd be good to document.
So actually, yes, if you think that it's not recommended, then we should for sure document it.
Well, I guess I'm certainly. I mean, if the terms of engagement here are going to have to do that, I guess I will. But I guess what I'm saying is that the extent to which you think these documents have force, like this document has force, even moral force or instructional force or educational force, then it ought not to do things that we know are not really that advisable, and the fact that I think there are a bunch of people here have been working on something which obviously is better, suggests that this is not super advisable. So I'd be happy to simply have it removed, but if it's not going to be removed, then yes, I'm happy to some sort of screed about why it's bad.
I'll just say one thing and I'll walk back to the, I think it's important to say why, not just what.
Martin Thompson, I don't want to litigate this right now, but I know that people are doing this already. The people who are doing the Quic API for the web are doing exactly this, inadvisable or not.
So actually, if you have real concerns about it, if you can give me arguments why this is bad, that's what we should document.
Right. I think that's all you need to know right now.
Okay.
Spencer Dawkins says the outgoing transport area director responsible for Quic. Partial reliability and FEC and stuff like that are still out of explicitly out of scope for Quic as it is chartered today. So that probably has a great deal to do with why the working group's not working on it very much, which is good, probably. We should talk, but that's the mystery of why it's not being worked on today in the Quic working group is because it was explicitly excluded in the current charter, I believe.
Ian Sweat, Google. I wanted to add that I think it's fine to say nothing in this regard, especially given Spencer's comment. I think that's totally acceptable. I also want to argue that this totally works. You can deploy this in a fairly large application and use 1 million streams and make them all unidirectional and make them unreliable, and it totally works. You can run a VPN over it. You can do a whole bunch of other stuff over it. So I think arguing that it's completely non-viable is a little bit facetious. Okay.
So Eka, can you add your arguments to the issue? Just add some comments there and describe what your concerns are.
I mean, one argument would be that we are going to, I think in Quic version 2, well, in the next version that the IETF will work, partial reliability has specifically been proposed as one thing to work on. So it seems kind of weird to have an ops draft give a way to do it and then have another way to do it in the future version of the protocol.
I mean, the point is we're not giving them a way to do it. The way to do it is already there. The question is, should we talk about it?
But personally, I think no, because would you rather have people do it this way, or would you rather have people do it the way that the future protocol will offer?
I mean, this section could say, you can do it this way, but hold on, we will do it in the next version. That's what the section could say.
Or it could say nothing. Yeah. And so absent consensus to say something, it says nothing.
Jana Iyengar, I'll agree with that. I think there's a problem here. And the problem is that when you talk about partial reliability as a noun, it's not clear what one is talking about. And you're going to end up having to describe that. And that's the problem. Like even when we talk about something that was excluded from the charter, that is quite different from what that is. Both of them are partial reliability. And that's where your problem lies. So instead of walking into that mess, it's good to stay out of it and allow applications to do what they do best. Use stuff. And we learn something from that.
Tommy Pauly, Apple. So I'm going to agree with what everyone's saying, that we shouldn't be mentioning the partial reliability hack in here, partly because we want to move on to other things, partly because like adding that kind of sets a precedence for, if we include this, could we include all the other wacky things you could do with the protocol? It could be essentially an unending list. Now, on the flip side, I think like things like how do we handle errors and how should applications deal with those are things that applications must face and they must have some behavior with. So I think adding text around that, things that are part of this, is important. So let's focus on the bits that we do need to give guidance on that are really current concerns.
Okay, let me ask you another question. Does it make sense to give more guidance on, like, because you can cancel a stream transmission, right? Giving more guidance on that bit, because that's what is exposed by some interfaces.
So I think actually to that point, giving guidance around when a given side closes a certain side of the stream, like do you send your stop sending at the same time you send your reset stream, or do you do them asymmetrically? Talking about the strategies of why you may do those things would be useful. And that kind of addresses this without getting into the topic of partial reliability.
The queue is closed.
Can you help with writing something?
Yeah, I'll give a PR for that.
No, it's closed.
Harald Alvestrom. I must say that I'm profoundly unimpressed by this discussion.
Okay.
We know for certain that this stuff that is up on the screen and described in draft is going to ship in product before the quick RFCs actually make it out the door. We don't have a choice. The only choice we have is whether we want to provide a forum for discussion of this topic at this time or not. If we do not provide such a forum, we have no influence, we as the IETF, over how that discussion forms and how the consensus forms. But we will have to live with the consequences of that consensus.
So Harold, nobody's trying to shut down the discussion on what shape partial reliability should take in Quic. It's specifically about this document.
I understand what you are saying. I am saying that we have a minimal chance of influencing what is happening, and making it sound like you're trying to push away the discussion reduces the chances that you have of influencing the discussion.
I don't think that's what the discussion is about. The discussion is whether an archival RFC that is going to live for a long time should mention what a bunch of people consider a hack when there's some other version to do things. Whether this ships or not, it almost doesn't matter, right?
Archival RFCs, we have a ton of RFCs that we have RFCs for ST4, I mean IP version 5. The amount of junk in the RFC series is large, and that's a positive thing. We should worry about how we shape the discussion and how we shape the community more than we worry about getting yet another piece of operational advice into the RFC series. Thank you.
Yeah. So Spencer Dawkins, responsible area director, talking about what I'm curious about, and my curiosity does not have to be satisfied here, is if people are already going to be doing partial reliability with one message per stream this way, whether there is what the incentive for doing partial reliability some other way might be. And like I say, that may be a conversation you all can have with me after the plenary. But you know, I mean, or any time doesn't care. Don't want to spend working group time on it. But as the guy who at least theoretically would be doing publication request, you know, handling publication requests for stuff like this, at least through March. Like I say, I'm kind of curious. It may be that the person who takes my place in March would also be curious.
Okay. So, Ted, we closed the queues a while back. That was an exemption for Spencer, but if you can make it brief, go ahead.
Ted Hardy at an architectural comment, actually.
Very applicable then.
And that is the way the charter describes how these things will be done as a series of extensions. And so there is an architectural decision embedded in the way the charter is describing partial reliability and certain other things as presumed to occur as extensions. And I think there's a question then that's about this document scope of whether it is describing the applicability of core Quic or whether it is also describing the extensions, whether they have currently been specified as standards track or whether they're available on the wire, because we know that this is happening. And I suggest that one way of getting yourself out of being wrapped around the axle in this is to put in this document that the considerations which derive from these extensions will be treated separately, and to create a new document which can then handle that.
In other words, limit the scope of our current ops drafts to the current set of Quic, like the current set of Quic RFCs.
Well, so simply, I put it the other way, is create another document that is for the extensions of Quic and the operations and manageability considerations for the extensions, and then make a forward pointer that says, go there, right there, give your PRs there when you have extensions. Because I think the other thing that you end up risking, and the point that I think Spencer was making, is that if you don't do it that way, you end up losing partial reliability fitting into this system architecturally as an extension. It becomes something that's an operational practice rather than a protocol extension, and those are distinguishable and probably not as good.
So at least for the manageability draft, it's very clear that we're only discussing this specific version of Quic because we don't know what other versions will look like. And maybe we can be more explicit about this in the applicability, but I think the same applies because like there are things we discuss which are not invariant. They are very version specific, so we can only discuss this specific version. I mean, like, yeah, I mean, like, if there are big changes, it just means that you have to also always add a new applicability statement, or it would maybe just be applicability section in a new document or whatever. I don't think we can avoid that. Okay, the last point on this slide is there is an issue describing the problem that even if you have configured your system to not expose a connection ID, it could still be possible that your transmission sends a connection ID, for example, if you do pass MTU discovery. So should we mention this and explain this to the user that this can happen? Okay.
I saw a thumbs up.
So Martin Thompson, if someone provides you with a text and that text is not bad, take the text.
Yeah, I think it's not a lot of text, so should be possible. So, but we need some input on the first two issues here. Yeah.
Would you like to?
I was just going to say that I was going to put Martin Duke on the spot here a little bit by saying that he's been doing some thinking on the first one, a fair bit of thinking on the first one, in terms of its interactions with load balancers and various other things. And it might be valuable to sort of figure out, not right now, but as that draft progresses, as that effort progresses, if that dovetails.
So yeah, there is already some text in there. The question is if we are missing stuff.
Got it.
Yeah, so Martin Thompson, I'm having a back channel with Tommy about this, the second point here. My assertion here is that if we don't specify error handling for the application level errors in the application level protocol, we have failed. And so having them in this document would be redundant. I would rather have them properly specified in those documents.
So,
now, Tommy asks whether the transport level errors would elicit reactions from the application protocol as well. And that's an API question. I'm not sure if it's quite, I'm not sure if I care about that. But if I were to care about that, I would expect the application level protocol to precisely specify what actions it expected endpoints to take in the event of receiving particular errors.
So I would like to disagree a little bit on your first point. So for the HTTP mapping, yes, you have to discuss those things in the HTTP document, but it's a general purpose protocol, and I don't think we will specify a mapping document for every single application we find out there. So giving some more general guidance might be helpful as well.
All right, we may disagree on that point. Okay,
We're super.
let's take this offline though, because we're over time.
We need to be more active on these drafts on the list.
So Corey first, PathMTU discovery problem? What is it?
No, it's an interface question. Should we, because it can happen that even so you configured your connection ID to not show up in the packet, that you might still have it in the packet for example, PathMTU discovery purposes. And should we warn the application about that this can happen?
I will think on this, but now I'll go to the PathMTU discussion next door in 6 months.
Sure. Okay, we have some more open issues. I put them on a separate slide because those open issues are more about, like, you know, what interface, what things should be exposed over an interface, and can we give any guidance? And as we don't have an actual abstract interface document, it's like not clear what we should do about these questions. For example, the first one is, in theory, it's possible that if you send 0 RTT data and the sender, the receiver doesn't support 0 RTT, and tells you 1 round trip time later, you actually could make a decision to not send the same data anymore, again, because they are outdated, and send new data instead. Should that be exposed as an interface to the application? And if that's exposed, what guidance should we give the application?
Mirja, Christian Wittmer. Mirja, I see a pattern there, because you're worried about trying to make general discussion of things that really belong in the application mapping.
Yeah.
I can easily see different applications making different decisions there. And I think that it does not belong in a generic draft. It belongs, if you want, the purpose of what we do is to ensure interop.
So
this interop will happen at the application layer. So if the application mapping doesn't describe what to do, we don't get application interop. So trying to get application interop without having the application specified, that seems to me very strange.
That's the whole question. If there is no general recommendation you can give, it doesn't make sense. If you can say this class of application should do this and this class of application should do this, it makes sense to give some guidance here. And I think, like, for the first point, it clearly is, right? If you are an application that might have, for example, if you send a request and you might be in a situation that, like, this request might not be up to date anymore, and you want to send a new request, then you don't have to retransmit the data, you can send new data. There's a general class of application that can do that.
I really believe that this is application specific.
Yeah.
I mean, this is a question I have.
Yeah, I think this one, at least, I'm not taking a general position, is application specific. In TLS, we concluded that you had to write a new mapping document for how to handle 0 RTT for, like, every single application. So I think probably this is the situation here as well for Quic, because Quic has, like, approximately the same, like, 0 RTT, like, properties as, like, as other applications. I know they're worse actually, because, like, there's, like, a pile of ways 0 RTT can be rejected. But like one way 0 RTT can be rejected is, like, ALPN mismatch, right? At which point you certainly have to do something that is not just retransmit. So I think, like, this is probably an awesome thing you can make a generic guidance on. I mean, like I say, like, TLS case is simpler and we punted it.
Subodh, I'd like to echo Ecker's point as well. That is, one application might choose to do both behaviors as well. For instance, if the ALPN matches after rejection, it might want to automatically retransmit. However, the ALPN does not match, then it might want to do another thing. So an HTTP application might want to do something if it supports 2 different ALPN types.
I mean, this is totally understood. The question I have is, if you have this interface, you have a Quic application, right? You have a library that provides you this interface. Is it so obvious what you can do with this interface that we don't have to recommend anything because everybody will understand this? Or is there something we need to tell people how to use this interface correctly for whatever application they have?
I mean, a more valuable thing would be the considerations of an interface between an application and the Quic transport. See, like, these are the options you might need to provide, and depending on the other aspects of what the interface provides, they can choose to express this in however they want. For instance, like, use different words for this or something like that. Like, Apple might have request idempotency, another thing might have some other concept which maps cleanly to these properties. But what might be better is like the general considerations of like, oh, if you do this, then this might happen. These are you might choose one of these things.
That's what I'm talking about.
Yeah, I think it would be useful.
Yeah. So we really do need to finish this one up, unfortunately. But Martin, really quickly.
Martin Thompson, I was actually going to make that point. I was going to say, all of these issues we have not had any discussion on the list, so we're not really prepared to have a good discussion here. Thanks to Miria for actually putting them up on the slides so we can see them, but I'd rather not discuss any of them here today.
And the question I have for the folks in the room is, put your hand up if you've read one of the last 2 revisions of these drafts. Okay, yeah, we need to have people take a look at these more seriously.
So I have one more general question here, because we've been talking about having a separate document that actually discusses an interface or an abstract interface or whatever. And like, yeah, you have a mapping there, but like, I'm actually talking about like these kind of configuration knobs or whatever that could be described somewhere. And I don't see this coming up. So that's why this is like all clustered on the slide, because I'm not sure what to do with this. I will not wait for this document anymore because I don't think it's showing up suddenly. So I guess the approach would be rather to, assume or make a recommendation. If you have this interface, you can do that, right? That makes sense. I think that's kind of what we just said. So okay, thank you.
All right. Thank you, Miriam. Okay. So let's go to the issues. Martin, do you want to do this? Okay. This presentation, yeah? Okay.
Famous last words.
So I'm not going to take any questions or comments on this one. I think I just want to make clarifying questions only, basically. We've had a lot of discussions about this one. The slides here are rotten, but they do contain some interesting things that allow me to describe the problem that we're talking about. So the problem here is that we have the potential for a server to be in 2 different states over time. So when you deploy a new version of a protocol or roll one back, there's this period of time where you can have connection attempts span that change. And you think you can roll out a cluster of servers and you upgrade some of them and have some of them still on the old version. You might find that clients hit one server instance and get a version negotiation back. And then they hit another server instance, and that server instance is expected to be able to produce exactly the same answer. And we kind of rely on that for the validation process that we do. Because the server's handshake message, the server's transport parameters contain essentially a copy of the version negotiation packet. And in the case where you're deploying a new version, you don't. So if you skip forward a slide or 2 slides even, the problem here is that the client will fail version negotiation because the 2 don't match. So that's problem number 1. Let's skip over the fix here because that's not a necessary fix necessarily. Skip. More. Oh, there we go. There we go back one. So the problem here, the other problem here is that we have an incentive arrangement with the current version negotiation scheme that that says that the clients pick the lowest possible version that they support, or the most widely deployed version. And so during the introduction of a new version of the protocol, the clients still remain incented to provide an initial packet in the old version, because if they guess wrong, they'll get a version negotiation round trip, and that's, round trips are money. And so you pick the most widely deployed version, and you ultimately are leaving the server with a choice. Well, you end up stuck with the old version, and you can sort of get around this by remembering things, that if you talk to the server and it supported a particular version last time, well, maybe you'll try the newer version next time. It's a little more complicated. You end up in some sort of suboptimal arrangements. People have noted, of course, that alt service helps where you have it, but that's not a guarantee. And so we're exploring a couple of options around solving these problems, and these slides covered one of the options that we discussed. I don't think we're done with that discussion yet, because I think I've heard about 4 or 5 new ways of sort of approaching this problem. Part of the problem that one of the solutions was do nothing, even for the first one, which is kind of a little bit odd, but if you think it through, it makes a bit of sense. So just wanted to make sure that people understood that we're grappling with this one at the moment. It's likely to take a little while before we sort it out, but this one's pretty high priority for those of us who are involved. If you have an idea that you'd like to add to the pile, I have a pile already, and we'll be sending a note to the list with a list of the things we've considered and the reasons why each one of them may be good or bad. Ek has already started a list, which is a pretty useful thing. So expect something very, very soon. I hope to solve this in 17, but we'll see how that goes. Several of the proposals change the invariants, so I'm a little leery about those.
That's it. Thank you. Go for it.
Martin, F5. So when a client gets a version negotiation packet, it is supposed to respond. The new initial is supposed to have the same destination connection ID, correct? Okay, so I think in the general case, that will be routed to the same server. And so we won't have this problem.
So the problem is that if you think about the way this is arranged, if that server's upgraded and it still remains, it's the same 5-tuple, same destination connection ID, the routing remains the same, you could still have a situation where you flip the flag that enables a new version in between the time where you sent the version negotiation and then when you continue the handshake. And the server doesn't maintain state between those 2 points. And so from the point that it sends out the version negotiation and the point that it sends out its flight of handshake messages, it can change its mind about which versions it supports. Now, of course, you can do things like take the server out of rotation and all sorts of other things like that. Those are some of the ideas that people have discussed, but ultimately you do end up in that situation. You could have.
Okay, Kazuho, my point would be that, well, the destination connection ID might change because it's not in invariance that the destination connection ID must be longer than 8 octets. It's a V1 specific thing.
Think about it. Okay, get back.
Okay. So the variance of transport parameters we were going to skip, correct?
So Martin, do you have the slide? Do you have Martin Siemens' slide deck for the issues?
I can look it up. One moment. Yes, I know.
Yeah.
About 5 minutes before the meeting started, if I recall correctly.
I thought you'd got them to him earlier. I'm sorry, Mark. I thought yeah. That's terrible.
You're a terrible
Do
person.
we have HTTP issues we can discuss in the meantime while our chair sorts?
Give it a second. I'm almost there, I think. If it's where I think it is. Although the network is being really slow. Come on, you can do it. Yeah, okay, well. Well, that's loading. Let's do the HTTP issues. Mike?
Plod. So when I go back and compare what the notable changes have been, it basically boils down to everything we agreed last time we were going to do is now in the draft. So go back and look at last time's presentation, and that explains the changes. Next. So a couple smaller issues that have come up since the interim in terms of exactly how we want to handle things at HTTP. We have this nice spectrum where how do we get the two settings frames from client and server, and what's the relationship between them? Right now, when you set up a connection, the first frame on the control stream in each direction has to be a settings frame. The client is not supposed to interpret any of the server's responses until it's seen the server's settings frame. The server is not supposed to send anything on a response stream until it's seen the client's settings frame. So in the 1 RTT case, the server sends first as the half RTT data. In the 0 RTT case, you remember what the settings were from the last connection. Client sends the settings frame in response to that, and then server will update it along with its responses. So in the declaration style, you send the settings frame as a statement of your own capabilities, and that's it. Kazuho had raised the possibility that we don't actually have noticeably more head-of-line blocking if we make this a full negotiation, where you have to see the other side's settings frame. Whoever speaks first, you have to see their settings frame before you can generate yours, which gives us the advantage that you can have the full offer select negotiation, but it departs more from the HTTP style. On the other extreme, if you go to pure defaults, then we eliminate the head-of-line blocking that currently exists. If you want a new slide. So we can get out of the head-of-line blocking box, but that has the drawback, which is true of the current system, that when you have that second settings frame, there's no clear marker as to when that takes effect. So you have some level of, well, this has always been true, but maybe I didn't know it was true. No slide. So basically where we stand is we're using the H2 style, which kind of has both of these drawbacks. And if we choose to step in one direction or the other, we could get rid of one of them. I don't know how pressing that is. My personal inclination is let's stick with what we've got, but both of these have come up and they have certain advantages.
So, Martin Thompson, I'm going to speak out against the two changes, although not too strongly against the defaults one. I noticed the full negotiation one, you have this situation where one side makes the offer, the other one makes the answer, depending on whether you're doing 0 RTT or not and whether you've accepted it, which gets a little weird.
No.
Client must know server settings before generating settings frame.
Which in 0 RTT, it remembers from the previous setting.
So you say the server always goes first, and the client always responds.
Correct.
Yeah, that's a little weird from the perspective of the arrangement that we have.
Mhm.
So I very much prefer not to have that one. I'm somewhat okay with having defaults for the purposes of alleviating the head of line blocking for things, as long as those defaults are really, really simple.
Yeah. So I think
no header table use, for instance, would be an obvious one. But we have some settings that are are not conducive to that, like the header block size.
Yeah.
So that leaves me back to the middle again, and I think that the head of line blocking is tolerable, and we've already got head of line blocking behind the handshake anyway, so let's just live with it.
Yeah, I hesitate with the defaults because the default would have to be you can't use the QPAC dynamic table at all, which is rather a drawback in having a sufficiently small request size.
Janai, I got it. I think I'm basically exactly what Martin said. I don't think that we have, given that the handshake packets are already head of line blocking, this is just one more packet after that. And I think it's completely reasonable. I'll leave with one question. Do we have a use case for the full offer negotiation, full offer select negotiation that is pressing enough to sort of try and push it this way? I know Kazuo is going to come up and say something to that. So I'm asking the question now and I'll walk out.
Yes, Kazuo, there's an actual use case for full negotiation, and that is that the peer can wait for the other, an endpoint can wait for peer's signal about QPAC decoder size, for example, and decide not to create QPAC encoder stream or QPAC decoder stream, and that helps memory constrained devices. And my argument, my argument for full negotiation is that in the current form, we already have the head of line blocking for the streams that sends requests. So having full negotiation just moves that lock to when you send settings. So it doesn't cause any practical difference between the implementations, nor about how much we see the head of line blocking. So that's my reason I prefer full negotiation.
Subodhanger, I'm kind of worried about given the current state of affairs. I'm definitely opposed to offer select semantics, but I'm kind of also concerned about the current state of affairs where you have to wait for the settings frame. And I know there's a lot of discussions happening, a lot of considerations around this. I much prefer the defaults mode because the settings frame, we've said that it has less head of line blocking, but we have no idea, for instance, right now, because you have to send, it requires you to send coalesce packets in 0.5 RTT, which is more complex to do. And some implementations might do it, some implementations might choose not to do it, but by default, you won't get the performance you need. And in HTTP2, you have this kind of defaults mode right now where the client speaks first before seeing the settings frame. So we know that kind of works and it's reasonable performance. The other point I wanted to make is that having defaults might also unlock the ability to use the defaults in 0 RTT as well. Currently, when we're looking at implementing the API to store transport parameters, QPAC parameters and other settings frame parameters in 0 RTT resumption, it is kind of painful to do. It is doable, but it's definitely not for not for the faint-hearted. So in that sense, it might make it simpler for people who want to use defaults and who have not seen settings frame to see, I will get a reasonable amount of performance, but I won't get the extra performance I get by caching the settings frame in case that they are bigger than the default values.
Alan and Dimitri on Jabber would like to say that in both implementations, they've decided to default the QPAC table size to 0 if they need to send a response before settings have arrived. And as Eric Kinnear and myself, there is some attraction to getting rid of the header line blocking and doing stuff with the defaults. But again, if that puts us into an awkward case where, yes, you've gotten rid of the head of line blocking, but you're now effectively head of line blocked on doing anything useful anyway, does that really help?
So I could also see a world where we go halfway, that we allow the server to respond in case it hasn't seen the client settings frame, but we can be pretty reliable that the client has seen the server settings frame before it gets there, before it sends any requests.
Yeah. So Martin Thompson, I'm hearing a lot of people saying defaults are okay, but I just don't know how to implement it. So if we could see how that would be implemented, then that would be great. But I don't know how to do a default for header block size, for instance, because I know that someone's going to want something smaller than whatever default we pick.
Right.
And 0 is the only safe default we can pick, and that means don't send requests, which is a bit weird. It's not really all that useful at that point.
Mhm.
So that's well, you're back to header line blocking at that point. So I don't know how to solve that problem.
So Eric, can you? Yeah, yuck on that. Sorry. Different rules for different settings, which is scary, but not totally insane. To Martin's point about if you have things that you can't set reasonable defaults for, that brings you back to head of line blocking. Does that mean that for cases where you didn't need any of those values or that wouldn't have hampered you, there is some percentage of the population that is now unblocked and everybody else is just in the current status quo? Because that may be worth the complexity of doing it, it may not be.
Doesn't 0 mean that you don't compress headers, not that you can't send any headers?
No.
Damn it.
Yeah.
So
That's a
the
different
header
setting.
block size is measured by the size of the headers in it. And so that means you can't put any headers, pseudo headers, the works on the wire. So it's kind of awkward, right?
Yeah, so if I can interject, to remind folks, in H2, we have defaults that previously exist, but then once you get the settings frame, you could discover reality is lower than the defaults. And so you have to be able to deal with any setting reneging on itself. And there are cases where that gets really ugly. So one of the changes that we decided to take early on was to say, you can never reduce a setting, and consequently, you have to wait to see the settings frame to find out what it is. Prior to the settings frame, it's simply unset.
Yes, Kazuhoku, one of the reasons why HTTP2 behaves the way Mike described is because it depends on the TLS version to which endpoint starts speaking first. Because in TLS 1.2, the client speaks first, and in TLS 1.3, the server speaks first. But in case of Quic, we know whether the client speaks first or the server speaks first. So that gives us the possibility of having full negotiation. And I'd like to also note that Quic Transport actually uses that feature to do a better negotiation. So the current way of using the declarations form is actually contradicting from what the transport does. And to me, it seems to me that aligning how we negotiate to what the transport does would be a simplification. Well, transport does negotiation.
Transport parameters are declarative too. This is currently aligned to what the transport does.
Well, but for example, TLS parameters are negotiated.
Yeah,
Just to clarify, you mean in TLS, not in Quic, right? Because Quic transfer parameters are declarative.
All right, yeah, sorry, but what I tried to point out was that transport parameters extension of Quic is actually exchanged in a request response way because it's a part of TLS function.
But we have consistently avoided having either side formulate their transport parameters based on the other side's transport parameters.
Yeah, so while the transport mechanism for the transport parameters is as you say, the semantics of the transport parameters themselves are not of an offer select kind.
I agree with that, but on the other hand, that doesn't sound like a reason to not have a full negotiation, especially when you could omit opening quick Quic decoder stream, for example.
So offhand, I'm not hearing convergence on this. So discussion continues on the list.
Just one question. outside of the QPAC negotiation, is there any other feature that could use offer select among the set of things that we know about?
Of the set of things that are in the draft, no. I think that, to me, the primary use case of this would be mutually exclusive extensions. So I support 3 different varieties of priority scheme. Here are my 3. Now you pick one before you start sending me priorities. So clearly we would not have that in the draft to begin with.
I'm sure we can find another way to deal with that with the current scheme.
It's ordered. Yeah, if you have like a preferential, if you have a particular way of ordering things, then you could deal with that in declarative way too.
Right.
So then it boils down to basically, is the QPAC question compelling enough for us to move in this direction?
I'm inclined to say no, but do we want to hum?
Are we ready?
This is way past my pay grade. So.
I think we've got 3-way split on this one, haven't we?
I feel like it needs a little more discussion. I think we could take a hum
Yeah.
now and go in the wrong direction.
I'm with you on that one, because I've heard people arguing for defaults, but we don't know what that would look like.
Yeah.
I've heard Kazuo arguing for negotiation, but I don't know what that looks like. Not really. Sorry.
I think I'd like to see slightly more fleshed out proposals and some discussion on the list.
Do we,
in the spirit
do
of
we
the
want
speed
2
dating
PRs
stuff?
we can compare?
Well, in the spirit of the speed dating thing, perhaps we have something more fleshed out. I don't care whether it's a PR or simply an email outlining all of the design, but if we have something more fleshed out in a certain time, that would be very nice.
All indications are this bin bit stuff is going to take about 15 minutes tomorrow. So, you know, if you do it tonight, we can.
I'd like to take that back for version negotiation and hopefully solve that, but we'll see.
Jana Iyengar, for what it's worth, I'm not sensing a lot of love for the defaults one. So my read is it's a 2-way split, but I think we are in the weeds at this point.
Okay, let's move on for now, but continue on the list and flesh it out a bit. Yeah, thanks.
All right. So next one. All right. So we've also had it raised that because we have the length at the beginning of each HTTP frame, there are cases where the server application is going to be generating data without a defined size to end of payload, but at the same time having to write the header with each chunk that comes out when the chunks are potentially small incurs some overhead. And there was a proposal to have some way to mark that this is going to be the end, this is the header of the last frame on the stream. And everything else on the stream is probably data. There may be a use for this in headers, but data is the most compelling. So next slide. We can have a spectrum that right now you length prefix everything. And the argument for that is this is fairly late. This is not critical. It's a nice performance win, but it's not going to change the world. If we do something, data frames are the place where this gets you the most impact, but it's kind of weird that data is the special blessed frame. Or we could do something entirely new in framing. Initially, I was thinking length 0 means runs to the end of the stream for all frames. For some implementations, that's challenging. I've also heard the proposal to have a new frame type that says, okay, we're done framing. And everything else is just body.
Well, I want to apologize, Mike, but could you go back one slide? Because I think I just kind of like lost the plot for a moment here.
Okay. So basically the issue is you've got some application above HTTP that's dynamically generating content.
Sure.
And handing it back to you in chunks as it produces it.
Yes.
And you don't know how long that ultimate payload will be. So you can't just say, payload length, type as data, and start writing. But you have to take each chunk as it's handed to you, length prefix it, and put it on the wire.
Right. Yes, I'm with you here, but the stream frames do have to have their length, have the length field, right?
Yes, but this is inside a stream frame.
Okay, that's what I'm checking. Because they immediately they send it to the end of the tag. Yeah, sure. The implant thing. So you're talking about the interior length here is what you're talking about.
So this is saying, instead of having two wrappings that both have length prefixed, let's just let the stream frame be sufficient.
Do you want to say anything?
Okay. I'm trying to think about one thing.
Ian Spett, Google. Yeah, so I'm a very large fan of doing something here. The reason is I've spent like the last year trying to make Quic actually kind of fast, and adding layers of framing inside framing make it much more difficult to make large content serving fast. I'm not saying I can't do it, but the APIs, the more layers of framing and lengths inside framing and lengths you have, like it just becomes increasingly difficult on both sides to get this right and get all the abstractions right. And so mostly from an application performance perspective, like not having something here makes me sad. But I think the consistent rule is the most obvious one to go with because it clearly has a use case personally. I'll also point out that 0 is currently defined as invalid right now. We're not stealing a value or something. We're defining something that currently, if you receive a 0, you are supposed to close the connection. So we're actually defining something that's currently undefined. But yeah, this would be massively valuable to us. I mean, it's nice to save the bytes, but it's mainly, I think it's going to make a lot of implementations of Quic a lot faster. And that was a big complaint of H2 over and over, is that it's hard to make a fast implementation. And now that I've looked at ours, I know why.
Yeah, I mean, I guess now that I thought about it, I have some sympathy for this. I guess I sort of feel like the fact that we're having this discussion means we went wrong somewhere in the design earlier when we already had this mechanism for having frames and chunks, and then instead of having these things which you want to be non-demuxed on a different thing, they're glued together in some long sequence of bytes which you have to independently demux.
Well, so the history for that is Google Quic puts the entire body on a separate stream, so you don't have this problem. But for covering the full flexibility of H2, you have to be able to put a push promise in the middle of the body and have consistent ordering. And the only way you get that in Quic is to have it on the same stream, so you have to have frames for the body as well.
As I say, I have some sympathy for this, but it doesn't mean I don't think we went wrong somewhere earlier. Yeah. But perhaps this last thing is the right answer given where we are in the design cycle.
Jana, I think you got 1 point right. We went wrong somewhere, and I blame push. As I think many people would. I think this is the idea of what special frame is very appealing to me personally. It's purely additive for people who care about it. In terms of a feature anyways, of course, but it's more code and so on. But I think that it's a nice way to handle the special case where you really don't care for all the frame. So just imagine a beautiful, perfect future world where there is no push. You don't really need, you could just use, all of your bodies could just be this, right?
Unless you have trailers.
Yeah, fuck trailers too. But
hoi, 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 hoi. Language.
Oh, that's of course. And that was the problem. Yeah.
Don't take my trailers.
Yeah, I know. Sorry about that. Fair enough. But even there, the common case is that you're going to have just body on these streams, and I think it's worth spending just a little bit of time thinking about how to optimize for the common case. And if you can do the same thing, which is the previous slide, there's the length, and I suggest that you use a length of 0 and a type of 0 for this new frame type thing. It basically,
I think type of 0 is currently the data frame.
Right. So this then becomes the length of 0 for the data frame. But anyways, that's encoding. Treating this specially is, I think, valuable to do because I expect that to be the common case when you're looking at bytes on the wire.
The other place where having it supported in other frame types may be valuable was that you can do the headers. Client requests typically do not have a body, and so you just put a headers length of 0 and then write the Quic from there.
So looking at the time, I'm going to cut the queue.
From Jabber, Dimitri says to Ian that you'd still have to support peers that frame data, which means that the complexity argument is moot unless you advocate dropping sized HQ frames.
Kazuhawk just wanted to point out that server timings as a trailer is a pretty useful use case for trailers. And I hope that many servers will support that.
Anything else on this?
Yeah, I think here again, we'll send concrete proposals.
More flesh it out and take
Yeah.
the list. Yeah, okay. Good. Ready?
Yeah. All right. One more issue that's been brought up, again, something that we have somewhat lost in the transition from H2. In H2, you have the priority information embedded in the headers frame, and then you can use priority frames subsequently to change it. We can't do that with Quic because you don't have a defined ordering between things, and so priorities have to be on a stream that gives you a consistent ordering of all the changes to the priority tree. Now, the issue that creates is until that priority frame arrives, you don't know what priority the request should have. And it's possible that a request comes in, gets processed, and starts streaming back before you ever discover where it fits in the priority tree. So I don't really have a proposal here because everything that I have been able to come up with is still subject to ordering can screw something up. And so I think here the question is, how upset are we about that? And if we are upset about it, does anyone have any bright ideas that they'd like to contribute?
So Martin Thompson, I wanted to add to the pile. So Bo would ask the question, so what's the default priority? And in H2, the default priority is you're attached to stream 0, because stream 0 is the control stream.
Yeah, root of the tree.
Whoops. And so there is that problem. Root of the tree is the answer. We have a default, and I think we just have to accept the fact that we have a gap and live with it, because ultimately I'll use the F word in conjunction with priority, just like Jana did with push. Yeah. Fun. So I think we just have to accept it and move on.
Okay. Does anyone feel strongly in the other direction, or shall I close the issue? Okay. Next.
Is it worth adding a little text, maybe?
Yeah, definitely one thing that we need to mention. Right now, we point to 7540 for the priority scheme, including the default priority of requests when they are first issued. We should probably at least clarify that you're not actually a child of stream 0, you're the child of the root of the tree.
But also talk about the gap, maybe.
Right.
Yeah.
Okay, so next slide. The last question around the HTTP draft is about naming. And I'm kind of, what was that?
Go on.
So I'm going to pull from a children's story that my cousin introduced me to last week. Next slide. Where Mrs. McCabe has 23 kids, all of them named Dave, and she's really regretting that choice and coming up with all sorts of names that she wishes she had given them. But they're already named, and it's too late. Well, Quic is not yet in this situation.
Weepy weed, really?
So you're saying we should name this Zanzibar Buck Buck McFate?
I second that.
How do you find that?
How about Quickie McQuick Face? I don't know.
John and I agree. It's pretty much done. Go
All
on,
right,
please.
next slide. Okay. So in terms of what we call HTTP over Quic, which does not exactly roll off the tongue and doesn't have an obvious relationship to HTTP 1.1, 2. Please stop calling it HTTP 2 over Quic. It has changed dramatically. It's really not that. It's not really Quic because Quic has the transport. And when we discussed in Montreal several of the changes that we've made in HQ and whether we want to bring them as extensions to HTTP 2, the decision was no, we don't, because Quic is the future, assuming all this works out, and we should keep moving forward. So that suggests perhaps a name that does have a relationship to H1 and H2, indicating that we're continuing to move forward into the future.
We got a logo.
Turn it off. Turn it off.
First, let me say those eyes scare the pants off me. I'm talking pure about, a pair of pale green pants with nobody inside them. I mean, I'm not going to lie down on the road over this, but I think it sucks. It gives the impression that nobody should HTTP is deprecated, which it is not. It gives the impression that if we ever want to extend HTTP 2, we're not going to. And I mean, fundamentally what this is a fork with one fork getting longer and one fork not getting very long very fast. That's what operationally is happening. And maybe we decide not to do a lot of maintenance on HTTP 2, and maybe we don't. But this sort of it's just a weird branding choice. But I've said my piece. If I'm overruled, then I'll shut the fuck up.
If I can just respond to that real quick. H2 didn't deprecate H1. So I'm not sure where you're getting those implications.
And TLS 1.3 has not deprecated 1.2.
It obsoletes it. It's precisely what's in the header. Yeah.
Well, H2 did not obsolete H1.
We go around telling people they really ought to use H2. If you,
aren't we going to go around telling people to use Quic?
I think that we're not going to go around telling people you ought not to use H2, you ought to use Quic, universally no. So again, I'm not going to lie down on the road over this, but I don't think it's a great idea, and I'd like to see a hum at least.
Sure. I would probably tell people the same thing that we actually do tell them about H2, which is you should use H2 unless there's a reason you can't, in which case H1 is there.
And Jen Iyengar, so many thoughts. First, that totally looks like a Zanzibar McFit.
I'm going to get that off the screen.
Oh, come on. Oh, come on. This is...
It was causing Ecker to remove his pants.
And that in itself is scary.
It's gotten my creative juices flowing. This is lovely. Ironically, you said Quic is the future. And this is ironical because it depends on which Quic you're talking about, right? There is a Quic, which is the present, and that points us to a problem here. We already have a Google Quic and an IETF Quic, and we have trouble keeping them apart. So I think it's very useful to have a new name first. Second, I'll agree with Ecker that there is a little bit of signaling issue here. It'd be nice to have an H2 prime, but we can't. Maybe we can. It is ASCII representable. Can we do H2 prime? The chairs are staring at me, and I'll take that as a no. Given that everything else is a rat hole, I think HTTP 3 is the best idea that makes sense. But yeah, I mean, I can get behind HTTP 3, given that we might have to make sure that the signaling is meaningful around that.
Sure. And so I want to emphasize when I sent the email out that instigated this, I pointed out we do not want a rat hole on this. We do not. Look at that cue. We do not want to spend a tremendous amount of time. We want to see if we can get to consensus on this proposal. So let's not throw other names out, please, quite yet.
And I will emphasize one other thing from the email, which is that to call it HTTP 3, I think we wanted the HTTP working group's input anyway, but to continue their naming sequence, we probably want their okay on the name change as well. So we'll be
probably.
Yeah. So we'll be discussing that in the HTTP working group tomorrow. Yes.
Yes.
Ted Hardy, and I was actually getting up to ask a scoping question, right? So there are places where the string will appear in protocols, and there are places where you intend for the string to be in the signaling you're giving to the larger community. Do you think those two actually have to match? Because in the strings, I can certainly see a reason for doing HTTPQ v1, right? HQ1 as an indication in the protocol string of where we are. This is HTTP over Quic, the first version of same. That's different from HTTP3, but in a protocol version reasoning, it may be the right thing to do. I wouldn't go signaling to people with HQ1 because they're going to get confused with Amazon and HQ2. It's just not, it's not good marketing, but it may be good protocol. And I think you should be very clear here which scope it is you're trying to solve here, because otherwise the rest of these rats in the line, and I'm counting myself as the first rat in it, are going to be trying to brush different colors on the shed without knowing which shed it is they're trying to paint.
So I will bring up an email to answer that question. And I believe it states, hopefully fairly clearly, where to go? Here we are. We rename our the HTTP document to HTTP3 and using the final ALPN token H3. And just to respond to Ted there quickly, personally, I think that having divergence between the token and the name that we use for the protocol is not going to help solve any confusion.
That has worked really well for TLS 3.4.
Colin Perkins, I don't really care, but why don't we just call it HQ since everyone's going to call it that anyway?
That's okay.
Pat McManus, I'd like to emphasize that this, while we will talk about this in HTTP BIS on Thursday, as the previous slide had talked about, this really is sort of an outcome of HTTP BIS's previous discussion in Montreal, and sort of underline some questions people ask, like, is H3 a successor to H2 that we would recommend? I mean, the answer to that would be yes. I mean, we really do, without deprecating it, but we are saying that we believe this is superior, and that's why we're pursuing this work. And similarly, it's going to maintain the backwards compatible semantic promises of HTTP, which are being better stated with HTTP core right now, but have always existed, and that is compatible, which is much more obvious for HTTP3 than it would be for Quic, right? Because that's all in line. So yeah, this is obvious, and the discussion we had about backporting features underlines the fact that the HTTP working group is willing to take on maintenance of this and view this as the place where new extensions and things should really be focused.
Kazuhoku, please call it HTTP3 because many logging systems only expect the version number to change. And please don't call it version 2.1 because we've already said that version 2 wouldn't have a minor version number, and that's how people expect.
Spencer Dawkins, probably for the for this moment, is responsible area director. Just as a thought for the chairs, Benoit, as the ops area director who became the Yang area director, had a proposal for semantic versioning and stuff like that for Yang models and things like that would be moving very quickly. It might be worth taking a look at that and seeing if that was something you wanted to come even close to. Touch, and I don't mean close to using, I mean close to touching. But there are other places in the IETF that are wrestling with version numbers that are with versioning for things that are moving pretty darn fast. And so just as a personal observation, so speaking as an individual, I spent enough time hanging around transport when transport changes usually meant operating system upgrades on a good day. to where the idea that a version of something could change as quickly as quick versions could change if the working group agreed on it quickly, agreed to move quickly.
So the underlying transport
Yeah.
will hopefully rev quickly, but this is the HTTP binding, which hopefully won't.
Okay. Cool. So like I say, it's convenient that they are semi-tightly coupled together. Back to speaking as an area director, and then I'll sit down. Whatever you guys decide, as an act of love and devotion, please make any needed charter changes before the new guy shows up. Because I think the new person may hate me for other reasons, but I would like for him or her to like me because of
Why
you.
do you say that?
If you believe that we need to make a charter change to change the name of our deliverables, we should probably have a chat to make sure we understand each other. We can do that offline.
And I'm a little confused. I'm just looking at the line that says beginning with HTTP2. So, like I say, I think it's always
Sorry,
good.
line in the charter, or
Yeah.
Okay. Well,
So, like I say,
let's take that offline.
And having a chat is not a threat any more than having a discuss on a document is a threat. So, please let's chat. I'm here all week.
Okay. I'm going to insert myself in the queue virtually as me. So imagine I'm standing over there. From my personal standpoint, the naming of HTTP needs to stay within the control of the HTTP community. And so I think that this needs to be driven from them. Logically, it's our deliverable here, so we need to have the conversation here too. HTTP is defined by a core set of semantics that is not version dependent. And in my opinion, calling the deliverable anything but HTTP3 sends a confusing message about the lineage of HTTP and how it's forked. It looks like a fork if we don't call it HTTP3. So I'm 180 degrees from Ecker on that. And so I'd ask folks to keep that in mind, that we're not naming Quic here. We're naming an HTTP version. And we should follow the conventions of HTTP versioning and let that community make the decision. Martin.
So Martin Thompson, I agree with that, apart from the point where you said that it looks like a fork, which I agree with. But the implied thing was that was bad, but it is a fork.
Well, no, a fork at the semantic layer, because while the people in this room are concerned about implementing what happens in the wire, 99% of the people who deal with HTTP are dealing with it from the other side of using it as an application protocol.
Sure.
And we don't want to confuse them.
Yeah, as long as it says HTTP in the name, I think I'm happy.
That's that.
All right, thank you, Mike. So we should hum that one up.
All yours.
Okay.
This is your house.
This is my house. So are we ready to hum on that then, to get a sense of how people feel about renaming that document with that proposal on the screen? Okay. So I'll do 2 hums if you support renaming to this, and then if you do not support renaming to this. Make sense? Okay. So please hum now if you support this rename to HTTP3. And please hum now if you do not support this renaming. I will let my co-chair characterize the hum.
It's pretty strongly in favor from where I'm sitting, but there was some non-zero objections. So I would say like 70-30, something like that, maybe.
Okay. So normally with this sort of thing, I think we'd say take it to the list. I'm a little wary of doing that. I heard people get up and say that they didn't like it, but they wouldn't lie down in the road. Is there anyone who feels that this would be an issue that they would be incredibly unhappy about?
Mia Kulevin, do you want to hum if people are okay to let the HTTP group decide?
That's a great question. Thank you. I'll do again a yes hum and a no hum. Yes, if you support that, taking it to the HTTP working group.
Does anyone disagree with this?
Well, I hope not, but let's find out.
Because they could just come to the mic and say.
Okay.
I mean, you don't have to hum everything.
Well, the point of humming is that you can express an opinion without, putting yourself through the trauma of getting to the mic. I know it's easy for you. You do it a lot.
It's a large room.
So if you support letting the HTTP working group decide this, hum. And if you do not, please hum. That was nice and straight. Cool. Okay, thank you for that. We're running low on time.
Yeah, we got 5 minutes. I did a quick agenda rebash to make it clear that the if time permits stuff that we might not get to all of it or any of it today will extend into the overflow time tomorrow, where hopefully, since the spin bit discussion apparently takes 15 minutes, we're going to have lots of time. But is any of those presentations, can anybody make useful use of those 5 minutes? You can, Martin? Okay, go.
If I have it.
Come here optimistically and we'll see.
This one?
So I was talking about initial packets with Christian at the hackathon. Next slide. And we always talk about the injection attack. That an on-path attacker can disrupt the connection during the handshake, but not afterwards. And it turns out that as things currently stand, this is not quite correct. So what an attacker can do is he can send a spoofed initial packet, for example, containing a connection close frame or containing a malformed packet, containing a malformed frame. There are endless possibilities how you can cause a protocol error that would close the connection. And what we currently do is we say that every endpoint accepts and processes initial packets, at least 3 RTOs after all initial data has been received and ACKed. And since at that point of the handshake we don't have a good RTT estimate, 3 RTOs might be as much as 600 milliseconds, even on fast connections. So this would be after the handshake, long after the handshake actually completes. If you look at the diagram, we only need initial packets in the first flight until more precisely, until the client has received the server hello. When the client has received the server hello, it switches to handshake keys, and it won't need the initial keys anymore. And for the server, as soon as it receives the handshake packet, it knows that the server hello was received and doesn't need to be retransmitted. So it doesn't need to accept any initial packets after receiving the first handshake packet. So what we have here is basically a 3-way handshake, and only during that 3-way handshake can an attacker disrupt us if we stop processing initial packets. Next slide. So the proposal here is to treat initial as the special snowflake that it is. We should stop accepting and retransmitting initials at the points that I just described, which are different for client and server. This has a few implications for how we do loss recovery, because stopping to process initial packets also means that we might not receive an ACK for a packet that we send. For example, the server might never receive an ACK for the server hello that it sent. So we need to have some text about that the server should actually stop retransmitting the server hello even if it didn't get the ACK. And there are some implications for congestion as well. Because we need to tell the congestion controller to remove those bytes in flight. This is something we need to do. We need to do anyway. It's just made very, very pressing with this issue if we actually stop hacking. Yes, Martin.
Thank you for raising this issue. PR 1819 was my attempt to deal with this by basically allowing receivers to drop initial packets if they disrupt the connection in exactly the circumstances you described. That PR has died for lack of enthusiasm, I guess. I'm not sure what the process is to resurrect it, if people want to resurrect it, or if the people who killed it want to explain why, that's fine too.
I think the issue was that with your PR, you would still need the ACK, right? So you can't just stop processing initial packets.
So I know that we just ran out of time, and one suggestion would be that since there are people at the mic, be really quick, and then also catch Martin, and maybe you guys can chat and tell us what we're going to do with this tomorrow, briefly. But go ahead, Kazuo.
And where's the other blue sheet? Anyone? Thank you.
Kazuho, we've repeatedly had this discussion since May, where we changed the TLS handshake design. And I'm not against having this information in the security considerations, but I would oppose to changing this at a later moment.
Why? This is leaving
this
open
is an
attack.
optimization.
No, it's not. It's closing an attack surface that we are
I mean,
currently
optimizing against attacks.
Yes, which is different from shaving off bytes.
All right, so this is the end. We got the blue sheets. Thank you all. Come back tomorrow. We hopefully will get to more of the, if time permits, things tomorrow, including a Q&A on them.
Maybe 20 minutes in the spin bit. We need to go and talk to